All right, today is chain rule part 2 at first. And then we're moving on to something that does not take very long at all to do, and that is differentiating generic functions. Okay? So, we're going to look at a problem very similar to the one that we ended with yesterday. And it was one that involved both the product rule and the chain rule. So look at this problem right here. Y equals 8x plus 3 to the third times 2, 1 to the fifth. Eight x plus 3 to the third times 2x plus 1 to the fifth. Okay. Do you see chain rule within that problem? You have a function inside of another function. Okay. Do you also see product rule? The fact that you have two functions that are multiplied together means you're going to have to use the product rule. So we're going to do product rule and chain rule. And you may think, well, where am I supposed to start? Which one do I do first? You do the one that encompasses the entire problem. Okay? Chain rule is for parts. The product rule is for the whole thing. Does that make sense? So we start with product rule. All right? Now, I'm going to do this problem just for space sake and not write down the outer and the inner. So hopefully you guys will get the hang of that and not have to write it all down. So, who remembers the way to remember the product rule with ones and twos? 1d2 plus, you got to say plus, 2d1, because you don't want to get that confused with low d high minus high d low. Product rule is plus, quotient rule is minus. Bless you. So, y prime equals 1d2 first. So 1 means we just copy the first one down. 8x plus 3 to the third. 1, excuse me, times d2. Now, if I'm going to take the derivative of 2, I have to use the chain rule. Okay? So if I'm going to use the chain rule, the outer function is the parentheses to the fifth power, right? How do you take the derivative of that? 5 parentheses to the fourth. So that's what I write down. 5 parentheses to the fourth. What goes in the parentheses? The 2x plus 1. Okay? Then, don't forget at the very end, you must take the derivative of the parentheses. What is the derivative of 2x plus 1? 2. We write times 2, close parentheses. So this is 1 times d2 plus 2d1. So 2 means, let's copy down 2, 2x plus 1 to the fifth times d1. Do I need to use chain rule on 1? Yes, I do. So it's parentheses to the third, so it's going to be 3 parentheses squared. What goes in the parentheses? 8x plus 3 times the derivative of the inside of the parentheses is what? 8. Okay. Did everybody follow at least that far? That's the calculus. The rest of it is cleanup. And the cleanup can get kind of ugly. All right. Look at everything up to here. Everything is multiplied together. What are the things that you see that you can multiply together? 5 and the 2. So it's going to be y prime equals the 10 times the 8x plus 3 to the third and the 2x plus 1 to the fourth. So I just brought the other two down. Are you with me? Plus, what about the second half? What can I multiply together? 8 and 3, and that'll leave me 24, parentheses. I've got a 2x plus 1 to the fifth and an 8x plus 3 to the second. Do you agree with me up to this point? Okay. Now, I went kind of quickly through this yesterday. I want to make sure I go slow now. Each of these is an individual part. I want to pull out of each what they have in common. Start with the numbers out front. What's the greatest common factor of 10 and 24? 2. So y prime equals 2. How many 8x plus 3's do they have in common? 2. So I'm going to write 8x plus 3 squared. How many 2x plus 1's do they have in common? 4. So I'm going to write down 2x plus 1 to the 4th. And then I'm going to open a bracket. And the reason I do a bracket, this number one is my teacher did it that way. Number two, it denotes the only thing you're going to still be messing with. This is done. This is what I'm going to work with. Okay? Now, look right above what you just wrote down and look underneath. This is what you had. This is what you pulled out. What's left? What's left between the 10 and the 2? 5. Do I have any 8x plus 3s left? I have one of those, so I need to write it down. Okay? Do I have any 2x plus 1s left? No. Okay? So move on to the next plus sign. Now look at, I'm covering that up. Look at what's after my finger here compared to what you pulled out. 4 and 2, what's left? 12. Do I have any 2x plus 1s left? Yes, 1. 2x plus 1. And then what about 8x plus 3s? No, they're both gone. That's squared and that's squared, so they're both gone. Close your bracket. Do I need to say what I just did one more time? Yes? No? Okay, yes. Be brave. Okay. Looking at these two right here. This is what I had. This is what I pulled out. What's left? 10. I had 10. I pulled out 2. That leaves 5. Because 2 times 5 is 10. Okay? 8x plus 3s. I had 3 of them. I pulled 2 out. That left 1 left. 2x plus 1s. I pulled them all out. So they're gone. Okay? That's why I didn't write a 2x plus 1. Then I get to the plus sign. So I'm done with that. 24 and 2. It leaves 12. I had 5 of those. I pulled out 4, so I'm down to 1. But the 8x plus 3s, I pulled them all out. So I don't have to write that down. So that's it. Okay, now, all you're going to do is clean up the brackets and you're done. So y prime equals, copy this first part down again. Bracket, and now distribute and collect like terms. So that would be 40x plus 15 plus 24x plus 12. Okay? So far so good? All right, last step. Recopy the front stuff. And then collect like terms. Now I'm changing back to a parentheses because I'm done. 40x plus 24x is 64x plus 27. And that is the answer right there. Okay? That is the totally factored, 100% simplified answer right there. Pardon me?
Is this chain rule stuff going to be on our test?
Chain rule will not. Product rule and quotient rule, possibly. Okay? Now, it is your turn to try one of these. Yes. Okay, work with your table. It's going to look exactly like that one. 5x minus 3 to the 4th times 3x plus 7 to the 6th. You try that one. Some of you will be doing stuff like this in your job, I know. 1, 2, 3, 4. Y prime equals. I'll fill in the answers later. That's what it's supposed to be. Oh, no. We did it first period. No, I can't do that in my head. There's no way. Okay. Any questions? Okay. Back up here, please, for the next problem. We're going to do one more chain rule problem, and then we're going to do the differentiating generic functions, and hopefully I'll give you time in class to work. Yes? Did you not get that answer? Okay. Let me come take a look real quick. Okay. All right, now back to this. I have one more kind of hard problem to give you off of that worksheet 3 from yesterday. After this problem, you should be able to do the whole worksheet. You're only doing the odds, though. So copy this problem down. Y equals big square root 2x over x minus 4. Yeah, if you looked at the Derivative Rules 3 worksheet last night, you saw a problem like this. Okay, this one involves quotient and chain. Quotient and chain, okay? Now, I have told you in the past that every time you see a radical, the first thing you have to do is change it to a power. So this is 2x over x minus 4 to what power? 1/2. Okay. Y prime equals. Before we start, which of those two is around the whole thing? Quotient rule or chain rule, do you think? It is chain rule. Chain rule encompasses the whole problem because the whole problem is raised to a power. Do you agree with me? You see that? Okay, so for this one, because it is so much uglier, I'm going to go ahead and write down what the outer and the inner are. Okay? What is the inner function? The 2x over x minus 4, the whole thing. Okay? And what is the outer function? Something to the 1/2. Okay. So we start the chain rule by taking the derivative of the outer. So how do you take the derivative of something to the 1/2? 1/2 something to the what power? Negative 1/2. So 1/2 something to the negative 1/2. That's how we start. What goes in the parentheses? The 2x over x minus 4. That goes there. No, because the quotient rule is inside of the power. So it has to be starting with the chain rule. Because whenever you take the derivative of something to the 1/2, you bring the power down. Okay?
You don't start off doing like the loaded high.
No, ma'am. Because that's inside of something else. Because the chain rule, there's a Lodi high inside of something else, you got to start with the something else on the outside. Okay. Good questions. Okay. Shh. Now, the process for chain rule is you take the derivative of the outer, you recopy that there, and then you do what? You take it. Now we got to take the derivative of the inner. Okay. And the derivative of the inner is the Lodi high, the quotient rule. So now we're going to do quotient rule as part of the derivative of the inner. Okay? So 2x over x minus 4. Low is x minus 4 times d high. What's d high? 2. Minus high is 2x times 1 over low squared. Low d high minus high d low over low squared. Every year in calculus, I have about 4 or 5 kids who do the quotient rule as low d high plus high d low over low squared. No, it's low d high minus high d low. Very important. Okay? So, I can clean that up some. So I'm going to leave now 1/2 2x over x minus 4 to the negative 1/2 times, let's clean that up, distribute the 2 in, 2x minus 8 minus 2x over x minus 4, the quantity squared. what can I do now? Cancel out the two x's. That sounds like a great idea. Okay. Can I cancel this 2 with that 2? What you think? Looks good to me, but honestly, the answer is no. What's causing me not to do it? The power. Power is locking that in there. Can't do it. Okay? So, what I am going to do is start breaking this apart. I'm going to make one big fraction bar with everything. Okay? I've got the 1 over the 2. Now, this whole fraction is to the negative 1/2 power. So basically, I'm going to separate it. I'm going to put the top to the negative 1/2 power and the bottom to the negative 1/2 power. So this is 2x to the negative 1/2.
Wouldn't the bottom be positive 1/2 power?
No, it's not. The whole fraction is to the negative 1/2 power. If I moved it up, it would be positive. Yes. Power distributes to both parts. Okay? And then over here, I have times a negative 8, and then an x minus 4 squared. So I just made one big fraction bar for everything. Okay. Couple of things I want you to notice. First of all, is there anything I can clean up? Can I cancel those two? Are they both free to cancel? Yes, they are. So let's do that. That goes there. That's a 4. So that's negative 4 right there. Now look at these two. They have the same base, don't they? So what do you do to the exponents? Add them together. So that would be 3/2. So now I have x minus 4 to the 3/2 power on the bottom. And I have a negative 4 and a 2x to the negative 1/2 on top. Y'all agree with that? Okay. Can I do anything else? Well, I'd like to leave it, but there's one thing I really need to do. Can't have negative exponents. So what should I do with that right there? With that right there. That one should drop to the bottom. So my final answer will be negative 4 on top. It's the only thing left. Then I have a 2x to the 1/2 and an x minus 4 to the 3/2. Doesn't matter what order you write them. Or, if it was a multiple choice, you might see it this way. Negative 4 over the square root of 2x times the square root of x minus 4 cubed. I would accept either answer on a free response, but on multiple choice you could see it either way. So I wanted to show you both of them. Any questions?